Today we are going to discuss a slightly complicated problem in mechanics where there is a wedge and on that wedge a block is placed. All the surfaces are considered to be frictionless. So let me explain this with the help of a diagram here. This is a wedge whose mass, let us say, is capital M, and on the top of the wedge we have got a small block whose mass is small m. The height of the wedge is h and it makes an angle theta with horizontal. We are supposed to find, number one, the distance moved by the wedge as the block reaches bottom. That is, when the block comes from here to here, how much distance will be moved by the wedge. Obviously, it will move to the left. That we have to find. Number two, we have to find the velocity of wedge as the block reaches bottom. Now, in order to understand this problem, we need to understand so many fundamentals of conservation of momentum. The first of it is when there is no external force acting, the center of mass remains at the fixed position, it does not move. So let us first understand how to go for it. Let us assume that there are two particles, say M1 and M2. This is the center of mass located at O. The distance x1 is here and the distance x2 is here. Obviously, by the definition of center of mass, we have M1 x1 equal to M2 x2. Now let us consider a new situation in which the point block M1 moves through a distance d1 and M2 moves through a distance, say, d2. These are their new positions. Obviously, this distance will be x1 minus d1 and this distance will be x2 minus d2. As there is no external force acting on this system, the center of mass must again remain at origin. Now if you consider the new situation, you will have m1 into x1 minus d1 equal to m2 into x2 minus d2. Let us simplify this. Please note that m1 x1 is same as m2 x2. So it will cancel and I will get m1 d1 equal to m2 d2. This can be taken as another example, separate example, which will clarify this point. If two particles are moving towards each other under their mutual action of forces and there is no external force acting, then the distance moved by the first block into M1 must be equal to distance moved by the second block into D2. Let us apply this principle in this case and let us try to find how much is the distance moved by this particular wedge when the block covers a distance from here to here. Obviously, we are interested only in the horizontal distance because there is no external force acting here. So let us try to find this situation in this problem. As this distance is h and this angle is theta, suppose let us take this as x, we know that tan theta is h upon x. So the total distance x is h upon tan theta. Now let us consider the relative motion of the block M and the wedge M, capital M. The total distance moved by this and this must be equal to x. But obviously, as M is moving towards right, this capital M is moving towards left. So we can say that the relative displacement is displacement of the block small m minus displacement of the block capital M. But since this displacement is to the left, I have to put one more minus sign so that the total relative displacement becomes displacement of M plus displacement of capital M. This relative displacement when the block comes from here to here is the horizontal distance, which is h upon tan theta. This is equal to distance moved by the small block, let us say x1, plus distance moved by the bigger block, let us say x2. So h upon tan theta must be equal to x1 plus x2. Now look at this equation, m1 d1 equal to m2 d2, which we have just now proved, and apply this in this case. I will have small m into x1 is equal to capital M into x2, so that x2 will become m into x1 upon capital M. Let me put it over here, and I get h upon tan theta. Sorry, let me get x1 in terms of x2, because we want to find the value of x2 here. So h upon tan theta is m x2 upon m, which is x1 plus x2. So let me take h upon tan theta is equal to, I will take x2 common, capital M plus small m plus 1, and that gives me h upon tan theta as x2 capital M plus small m upon small m. On rearranging, I will get the value of x2 as m into h upon m plus m into tan theta. So this is end of part 1, where we have calculated the distance moved by the wedge to the left when the block small m moves from top to bottom. The distance moved by the wedge is given by mh upon m plus n into tan theta. In part 2, that is to find the velocity of this block, this wedge, as the block comes down, we will have to use this result, which is mh upon